I honestly don't know how people who use Windows computers get anything done. Just waiting for the dumb thing to load takes forever. Alright, today, let's see, what is today, the 9th? We are a couple of weeks away from Thanksgiving here. And I was hoping that by today, or by the very least at the end of this week, we would have a little bit, we would have our drones for the project. They have not come in yet. And so we're going to have to cross our fingers that they come in very quickly. But we will move on to do some more training in SketchUp. You can never have too much training in 3D design, conventional modeling. Excuse me. Okay, so that is what we will do. Last time I seem to remember we were beginning to use the 3D warehouse, I think they call it, or something like that. But and again, I still can't download SketchUp onto this computer, so I've got to figure out a way to do that better here. But let us look at some more stuff here. Okay, so part 3 was where we were at before. In this next part, I believe we're going to look at building and modifying groups. There is a ability that SketchUp has to design something and then to create a group out of it, or to make it into an object rather than just a design of a bunch of lines and surfaces and everything else, so that you can move the whole object at once. You may have noticed if you try to move things in SketchUp that you've designed, it's not necessarily all that easy. Sometimes you move part of it and it stretches the object or rotates it in some weird way. And so it causes some problems. And the same goes for rotating objects that you've designed, whatever else. But there is a way to build something and then make it into an object in Google SketchUp, so that it's just like dragging around an object in any program that you would use. And that's what we're going to look at a little bit today. And we'll see where we go from here, if we have to watch more videos while we're waiting for parts for our next project. So let's go ahead and check it out.
Please be sure you have watched the previous Getting Started videos. We'll build on the concepts learned there. In this video, we will create a hallway table. We'll learn about using groups and components to better separate and organize the various parts of your model. We'll start by drawing the tabletop. Create a rectangle that is 14 inches wide by 48 inches long, and push-pull it up 1 inch. Now zoom into the...
So a very important thing to learn right away. They're building a tabletop and they don't start from the bottom up, which is how I think many people would design something. They would start from the bottom up or the top down or whatever makes sense to them. And they didn't. They're starting by making parts. And this is a very important part of engineering design. You don't want to design the whole thing all at once necessarily. It's often better to create components and put them together, see how they fit, and then modify from there. Because oftentimes your requirements are requirements that are on the components, not on the entire project. So first, you're going to have dimensions and requirements and specifications that you're going to have to meet. Meet those by creating parts that meet those. Then try to put the parts together in a way that works, and if that doesn't work, then you can modify from there. This is a very good example of that.
Corner and draw a line from this midpoint to a point on the lower edge. Depending on your preference, you can make this angle deeper or more shallow, and SketchUp will also give you an indication of an equidistant angle by turning purple and snapping to that angle. Finish your line and orbit underneath the tabletop. We are going to use the Follow Me tool to create a chamfer. We could manually follow the surface around the edges, but there is a quicker method we can use. Because we want to chamfer the entire lower surface, we can pre-select that surface, then pick the Follow Me tool and click on our angle to finish. Let's move the tabletop up to draw the legs underneath. With the Select tool,
I kind of want to have them demonstrate that again really quick. See, this is a very useful little feature. See if I can get out of my full screen here. So you remember the Follow Me tool allows you to create a shape somehow and then drag that shape around an edge, right? In this case, what they're doing is they want to put a little chamfer around the bottom of this table. The chamfer is a bevel, right? It's another word for bevel. But they're just cutting off the corner, essentially, kind of rounding off that corner with an angle. And so they make the angle on the table, whatever they wanted to make, and then the Follow Me tool is designed to go around the edge of a surface. And so if you select a surface, then the Follow Me tool knows that all of the edges of that surface are the edges that you want that little cutout or that little chamfer to go around. So they select the bottom surface and then they hit the Follow Me tool. So let's watch that again.
pick the Follow Me tool and click on our angle.
Didn't go back far enough, apparently. So what you would normally do is you would just drag it around. What they're going to do is they're going to do this shortcut
The
method.
Follow Me tool to create a chamfer.
So here's the
We could
drag
manually
method.
follow the surface around the edges, but there is a quicker method we can use. Because we want to chamfer the entire lower surface, we can pre-select that surface, then pick the Follow Me tool and click on our angle to finish. Let's move the tabletop up to draw the legs underneath. With the Select tool, triple-click one of the surfaces to select all connected geometry, and move it up in the blue direction 37 inches.
One more very useful tool. When you want to move things around, you need to make sure that you select everything. Okay, everything that you want to move, you select. If you don't select one of the surfaces or one of the lines, and you move it, that line will stay there that you didn't select, and all the rest will move and it will create crazy shapes. And sometimes it's hard to undo that by eye. You'll have to hit the undo button. If you remember that, it's on the Mac, it's the Command Z, I think, and then on the PC it's Control Z. But anyway, you want to know how to undo things, but you also just don't want to mess things up in the first place. And so it's a good idea to know this little trick where if you click on a surface or on a edge, and you double click or triple click on it, I think it was, right? It will actually select all of the edges and surfaces that are connected to that geometry. So anything that you've created that is connected to that geometry will be selected, and then you can move all of it using the Move tool.
Given our top is 1 inch deep, that will give us a total table height of 38 inches. Orbit underneath to start drawing the table legs. Draw a rectangle, starting from this corner, that we can pull into a leg. However, before using push-pull, let's say we change our mind and we want the leg to be inset from the edge instead. If we select and move this surface, however, it begins to warp the tabletop.
That's what I was talking about. That's what I was talking about, where you're moving one thing, but it's connected to other things, and so it changes the shape that you originally made.
On top of the other edges, those edges merged. This is a key behavior to making SketchUp fast and easy, but it's not what we want in this example. This is one of the primary uses of groups, which will isolate our geometry, preventing the edges from merging. To see this in action, undo the rectangle using Ctrl-Z on a PC or Command-Z on a Mac. Then, triple-click to select the whole tabletop. Right or context click on the top, and from the submenu, choose Make Group. A new bounding box is shown around the whole top.
So what he's done here is he's turned the top of the table into an object now. And you will not be able to connect this object to anything in your design. This object will be free to move around on its own. It will not be integrated into any other part of the design. And this is how the 3D warehouse works. When you design something for the 3D warehouse, it creates objects from those things, and then you can import those into and out of other things. So it's pretty simple. You right-click, you go to Group, and you create a group.
And it now behaves as a single, unique entity. Draw the leg rectangle again. Make it 2 inches long, 1 inch deep from the corner. But this time it won't merge with the edges.
So what's going on here is now you have a tabletop, and just right under it you've created a new surface. They're not connected. They may be touching, but they're not connected. This rectangle is a separate rectangle from the surface that you just drew it next to.
So if we wanted to move it around, we could easily do so. Create some guides using the tape measure tool. Pull a guide 1 inch away from these lower edges, then move our leg rectangle to those guides so it's inset exactly 1 inch. Remember to move the rectangle from the corner point for accuracy. Now push-pull the leg down 37 inches. Using the Select tool, triple-click on the leg to select all of it. Then right or context click on it to open the context menu, and this time choose Make Component. A pop-up menu will appear. You can name the component, and your settings should match these. We made the tabletop a group, and the leg a component.
So why would you make the tabletop a group and the leg a component? Can you think of a reason for that? Also, making it into a component, you've named it now, and you can actually use it in other parts of the drawing. We're going to have 4 legs eventually, so you can you reuse that component over and over again. The tabletop is just a group. We're only going to use it once, so we're not going to need more of them. But the leg, we're going to need multiple legs, so we might as well just design it once and not try to create different ones. And the other advantage of making it a component makes it also a group, and so it cannot be altered unless you ungroup it, unless you get into that group. So you can make the legs, and then the legs can't be changed and have your design of your table messed up.
At first, there may not seem to be a difference, but we'll see that there is a very important difference. Let's start with the similarities, though. A group or component binds the geometry together into a single entity. You can move, rotate, and scale the group as a whole. However, a tool like push-pull doesn't seem to work because you aren't affecting the actual surfaces, but the whole group together. To use push-pull and other tools, you need to edit the group. Use the Select tool and double-click on the tabletop. The bounding box changes, indicating that we are now editing the group. Still with the Select tool, click outside of the dotted surrounding box to close the group. Practice this a few times with our group and component.
So whenever you double click on a component or a group, you can get this bounding box here, this little dotted line box around it, which means that you can edit it. Which means you can actually start clicking on parts in that component or group and changing them. So you can change them once you've grouped them or made them into a component, but you do have to make sure that you get into that mode, that editing mode for the group.
Double-click on one to edit it, click outside to close it, and do this several times. While you are editing a group or component, you can draw and divide surfaces and edges, use push-pull and other tools. But once you close the group, anything you draw is outside of the group. So it's important to know when you are editing or working outside of a group or component. With that understanding, if you did modify your group in any way, undo any changes back to our original tabletop and leg. And let's copy the leg to the back side. First, create a guideline 1 inch away from the back edge. Then, as we learned in the last video, Start moving the leg, then press the Control key or Option key on a Mac to move a copy instead. Move the second leg into position using our guidelines. For comparison, also make a copy of the tabletop upwards so we can see what the primary difference is between groups and components. For the legs, let's angle the legs inward as part of the style of our table. Make sure you are editing the leg component, then select this lower outside edge and start moving it with the Move tool. The copied leg component is reflecting the same changes, and this is what makes a component very powerful. Any changes you make to one component are also made to any of the same components in the model. Move the edge inward 1 inch and close the component. For comparison, edit the copy of the tabletop and make some changes to it. The original tabletop stays the same because this is a group and every group is unique. So there is our overview of groups and components. Both help us to group geometry together, but each group is unique, where a component and any copies of it are instanced, so any changes made to one are made to all. As a general rule then, if you don't plan to copy an object, grouping it is fine. But if you think there is a chance that it will be copied, make it a component, and use groups and components throughout your model to keep objects separate and unique. Now let's return focus to our table. Navigate under the table and draw a rectangle between the legs that is 1/2 inch thick. Your width may vary based on the angle you created under the tabletop, but whatever the width, pull it down 6 inches. Now, triple-click with the Select tool and make this a component. Name it, and create the component. Let's copy this support piece and the legs to the opposite side of the table. Zoom out to get a full view of our table, then hold the Shift key down and use the Select tool to select all 3 parts. Now begin moving them down the length of the table and press the Control key or Option key on a Mac to make a copy and place them somewhere around the middle of the table, making sure to keep them lined up along inference directions. To know where to place them, we need to create a guideline as we've done before, 1 inch from the far edge. However, the direction these legs are facing is incorrect. We need to flip or mirror these parts. Make sure all 3 parts are selected and choose the Scale tool. Scale works by clicking to move the control grips. Any of the corner grips will scale everything uniformly. However, choosing a center grip will scale it only along that axis. Watch how this works by trying several of the grips. Pay special attention to the center grips, which scale along the red, green, and blue directions. If you squash the geometry through itself, you can mirror the object in that direction. To get a perfect mirrored version, watch the measurements box. The Scale tool works as a percentage. 1 equals 100%. 0.5 is 50%, or half the scale. 2 would then be 200%, or twice the scale. And if we pull the geometry through itself, it becomes negative. So -1 equals -100%, or a perfect mirrored version of our geometry. Undo any scale effects you have created. Select all 3 parts and scale along this center grip until you see -1, which the tool will also snap to, and click to finish. Now move the assembly into place using the corner of the table and your guidelines for placement. Next, let's create the front of the table. Zoom into a corner to draw a rectangle that is 1/2 inch wide by 6 inches deep. Then pull it across using the opposite leg as the reference. Select the entire table front with a triple click and make it a component. Now orbit underneath and copy this to the back, using inferencing for proper placement. Let's add a curve to our table. Orbit to a good front view and create a guide 1 inch up from the table front piece. Now edit the front component to draw a 2-point arc inside it. Drawing an arc is a simple 3-click process. Click once at the corner to start the arc. Click on the opposite corner, where the other side of the arc will be. Then pull up and use the guideline as a reference for how high to make the arc. Now you can use push-pull on the arc. Push it until it meets the back surface, which will delete it. Close the component. We won't create all the internal elements or drawers that a real table will have, But let's finish this example by creating the drawer fronts so our table looks complete. Draw a rectangle on the table front that is 3 inches by 15 inches wide, and pull it out an inch. Zoom in and create a chamfer as we did with the tabletop. Draw an angle, then select the front face as our Follow Me surface. Then choose the Follow Me tool and click on the angle to complete the Follow Me chamfer. We better group the geometry at this point. Triple click to select it all. And if we were going to center the drawer and have only one, we could group it, but I'm going to create 2 drawers, so let's make it a component instead. Now a few guidelines can help with the placement of the drawer front and the copy. Place yours where you think they look best. Perhaps as a final touch, edit one of these drawers, and using inferencing to center our circle tool, create a small drawer pull. Then close the component. Delete any guides we've created. Paint the table if you'd like, or add your own details. The very best thing you can do is just to practice and play with SketchUp, using these projects we've built together or new projects of your own. As with previous videos, there is much more to learn about using groups and components, mirroring objects, Follow Me, and other powerful tools in SketchUp. So please continue to explore more of our videos and training content.
Yes, the next thing to do. You guys don't have any holographic viewers, do you? You guys don't have any holographic viewers, do you? All right, well, I want to look at something else here. Alright, let's explore. I think I want to explore SketchUp's Google or SketchUp's YouTube station for a little bit here. Let's take a look at YouTube. I can't really think of anything that I want you to do for an assignment today. So let's look at, see if we can find. Let's see here, SketchUp, 245 videos.
You're back.
Navigation, 3D base camp. Let's
We're back with our newest version of SketchUp, 2017. Want to find out what's under the hood? Let's take a look. We've made numerous improvements to the basic toolset of SketchUp.
All right, we're gonna watch this one next. Let's take a little longer look at components and see if we can to learn a little bit more about making components. And maybe we'll look a little bit at the models as well. Yeah, let's take a look at this here. Let's see if this one has anything to offer. Is there no sound to this?
As you've worked with SketchUp, you may have noticed something we call sticky geometry. Basically, when you move one piece of geometry over another, they tend to stick together. This behavior is key to the way SketchUp works, but sometimes it is just not what you need. The way to keep this from happening is to group geometry together as a unique entity. In SketchUp, there are two ways to group geometry: as a group or as a component. In many ways, the two look very similar, so let's take a moment and examine the differences. I'll start by selecting this geometry. Right or context click on it and select Make Group. Now all that geometry moves and behaves as one entity. Now do the same for the component geometry. Select it, then right or context click and choose Make Component. Don't worry about the options in the dialog box for now. We'll cover those later. At first, the group and the components seem the same, showing a larger bounding box, indicating that this is a unique entity that acts as such. The primary difference comes when you make one or several copies of the object. Watch what happens as we edit and make changes to the group. You can see that we can manipulate each group separately. They have no connection to the original or to other groups. However, as we edit and change the component, all of the components change as well. You see, components are instanced, which means they are all linked to each other, and anything you do while editing a component will be repeated to the other components. As a rule, anything in your model that is repeated, even once, should be made into a component first. When you create a component, you cannot push-pull, move edges, or otherwise manipulate the geometry inside the component. You can only move, rotate, or scale the geometry as a whole. To change geometry inside the component, you must edit the component. Right or context click on the component, choose Edit Component, and you can then make changes as needed. Right or context click outside the component and choose Close Component when finished. Another way to open and close components for editing is with the Select tool. Double-click on the component with the Select tool to start editing. Then click once outside the component with the Select tool to close. You can see when you're editing a component by observing the bounding box. It is solid and highlighted when the component is picked, but becomes a dotted bounding box when you are editing. Any components that you create are stored in the component library. Access this library through the window menu. When you open the component library, you can see other components we've created for your use. To see components you've created or added to the model, click this house icon. Right now, this shows our one component. Look through some of the categories to find other components to add to the model. Simply click on a component, then click in the model space to place it in the scene. Additionally, if you're connected to the internet, you can search here in the component browser for models in the 3D warehouse. Look through your results and simply select one to download it and place it in your scene. After adding a few components, click on the house icon to see all the components that have been added to the model. This remembers all components added to the model, even if you've deleted them from your scene. If you wish to also delete them from the component browser in Model List, you can right-click on a component icon and choose Delete. This will delete any instances in your model that remain as well. A quick way to delete multiple components from the in-model view that have been deleted from your scene is to click this flyout menu and choose Purge Unused. Let's erase one of the components we added to our scene. It's still available in the component browser. However, when we purge unused, it's deleted from the menu. Components are far more powerful than we've explored here. Look into some of our other documentation for tips and ways to use components.
So I kind of like that. Gives us a little bit more useful information with components, and it also gives me an idea for an assignment that I think will work out for us. So let's come up with an assignment here related to our upcoming project. I would like you each to create a rudimentary, simple, basic drone copter, at least 4 propellers with 4 electric motors, a battery, a onboard computer of some kind, and a camera. Many of these things can be found probably on the 3D warehouse. You could probably find these components on the warehouse. But I don't want you to make it completely out of components on the warehouse. I want you to design at least 3 components for your drone yourself, and the rest of them you can draw from the warehouse. So I would pick and choose. For example, something like an electric motor might be fairly easy to design a simple shape that looks like an electric motor on Google SketchUp, where designing a propeller is probably a little bit more challenging for the advanced user of SketchUp. And so you might look for propellers that are available in the 3D warehouse. Keep in mind that you can edit components from the 3D warehouse. You can download them, double-click on them, or just click on them and edit them. You can also change their size and scale so that they can fit into what you need them to do. Then I want you to design a small drone, nothing bigger than the size of your hand, essentially. So just a few inches across and maybe an inch or 2 high. And this will be your assignment. Your next assignment from SketchUp is to design this rudimentary drone. Should have battery, onboard computer, camera, at least 4 propellers, and then we will meet again on Friday, and hopefully by then we'll be able to start our project with our actual drones. Any questions? So the last assignment, and that is posted on my YouTube channel, which is under MPCC Engineer on YouTube. If we close here and go up to search here and go to MPCC Engineer, it should bring up my channel here. And it does. So here's the last one, 1104. Maybe that's it, I don't know. But if we go to this one, it should show us. That wasn't the last one. The last one was 1107 right here. So here's that video. But we watched the video that involved designing this room. and then putting some furniture in it, and I was just going to have you design a room using these same techniques. It doesn't have to be the same exact room, but you should go through and watch that video on every technique that they use in designing things like windows, where they actually use some techniques to design three exactly identical windows. And I want you to use those techniques. They also started using the paint tools and the texture tools, and they also used the 3D warehouse. So that was the last assignment. And of course, this time we're going to move on to creating parts rather than houses. So components and other things. So any other questions? All right, I'll leave you to it, and we'll see you on Friday.